Welcome to the Turbocharging Onshape webinar. During this presentation, we will learn some of the tips and tricks and behind the curtains workflows that contribute to Onshape performance. I am your host, tour guide and bus driver, Philip Thomas. My email address and my Twitter handle is here. You're welcome to contact me at any time. So, turbocharging Onshape. I don't remember anyone that has ever said that Onshape is too fast. Everyone wants Onshape to be faster, but by many metrics, Onshape is faster. And the comparison that we draw is from soup to nuts, from start to end, compared to traditional CAD. Is Onshape faster? If we're not faster, no one should be using it. But in general, we are. That said, there are some specific workflows that can be slow, workflows that you're used to using in traditional CAD that will actually slow you down in Onshape. And there are some specific capabilities that, quite honestly, we have room for improvement on. It's not that we forgot to finish a piece of functionality. It's not that we think it's good enough. It's just that we had to move on and do some other things. And we're going to circle back around to things like the whole wizard. There are performance issues related to the whole wizard, especially related to sheet metal. We're very aware of this. We don't shy away from problems. People on the forums tell us these. We have tickets and votes. We know that these are things that we have to do. There's 100+ people here working very hard to improve those. And as you know, every 3 weeks we release new capabilities. That said, there are things that you can do to improve the performance of Onshape, and some of those are related to machines and settings, and some are related to workflows, and we are going to cover all of those. So during this presentation, we're going to cover some things to do in set. We're going to go with some best practices, and I'm going to try and explain some of what happens behind the scenes. Some of it is our secret sauce, but I'm happy to tell you a lot of what's going on. We're very open. We've published our source code. It's available for reuse, and we want people to understand how Onshape works. That said, the workflow around, I think I just invented a phrase, will be true for today, but understand that we are constantly working on improving suboptimal processes. During my research for this presentation, I spoke to a number of the system architects here who said, but we're working on that, meaning new algorithms, new workflows. So watch for changes in these areas. You're going to find announcements in the What's New forum and the change log when we release a new version. So try and close some of these things. At the end of this, I need to leave you with one golden rule. I'm going to tell you about 10 tips and tricks, but at the end, I need to leave you with one golden rule to leave with, which is the thing that you must do. So there's a bit of foreshadowing. Let's talk about the internet. We are a cloud application, and people always ask us, how much internet do I need? It's not about the size, right? It's about having a reliable connection. Today, we're not very tolerant of interrupted connections because we use SSL. When the connection is broken, we have to reestablish that. We start new sessions. This is one of those things that we are working on. If you use Gmail, you know that if you lose internet connectivity, it is trying to reconnect, trying in 3 seconds, trying in 5 seconds, trying in 10 seconds. Of course, we should be doing all of that. So size is less important than ping and route. So route is where there's the path that the message takes from your clients to our servers and back again, and ping is the length of time it takes. Quick bit of quantum physics, speed of light, 3 × 10⁸ meters per second. Sorry, European metric system rocks. But for you imperial users, that's 186,000 miles per second. So from where I'm sitting in Boston to Portland, my nearest server, 4,800 kilometers, right at 3,000 miles. Time of flight of the round trip at the speed of light is 32 milliseconds. File that number away. We're going to be using 32 milliseconds in a number of our calculations coming up. So what can you do to make sure that you're good to go for Onshape? There is a URL, cad.onshape.com/check. It is also directly accessible from your account. So from the help pull down, you can click on system check, and it will go ahead and run this check. And you're looking for a number of things. I'm going to let it run. It takes about 10 seconds. The first thing I'm going to say is you absolutely must have green check marks. If you don't have green check marks, clearly something is going on. So you need to be able to say that you have passed all of these tests We'll start there. Usually, if you're not using one of the approved browsers, you'll fail one or more of these checks. Today, that list is Chrome, Firefox, Safari, and most recently added Microsoft Edge. Microsoft finally came in line and made Edge compliant with the WebGL formats that we use. WebGL is supported by these other 3 browsers and most recently by Edge. So, great. We've got all checks. What's the next thing? Check that you are in the correct region. The region is shown at the bottom of the screen here. I'm sitting in North America. For anyone else sitting in North America, it should say US West 2. There are a number of other regions that we operate. Amazon, based on Amazon, has service centers around the world, many more than are listed here. And we've just chosen a number of geographically strategic locations to have servers spun up. So if you're in Western Europe, for instance, you'll be using EU West 1, which is Ireland. Basically, the fiber optic cable comes out of the ocean on the west coast of Ireland, and there's a big fat Amazon Web Services Center there, and that's where the services are hosted for Western Europe. There are additionally servers in Singapore, Tokyo, and Sydney. And I don't mean physical servers, I mean instances of our services running. If you believe, having run this check, that you are using the wrong geography, then it's likely that it's a DNS issue. For instance, if you work for a US company based in Eastern Europe, you might have all your DNS servers pointing to the Google DNS service back in the US, and it will say US West 1. So your time of flight, your 32 milliseconds, is almost doubled to 64 milliseconds. Humans can start to notice times around 100 milliseconds. So you do want to make sure that your DNS is routed correctly. I'm not an IT guru, and you probably aren't either. So basically, if you think you're using the wrong region, contact your IT provider. Now, this is not true for individual documents. We're going to talk about individual documents in a moment. Quick bit of nomenclature. There are modeling servers. These are a family of different services provided by servers around the world, and the actual CAD data. The CAD data lives in the region of the creator, and the primary consumer should create the document. Sorry, I don't know why it keeps auto-advancing. The primary user should create the document and then perhaps share with a secondary user versus the secondary user creating the document and sharing it with the primary. We are working on some clever stuff, ITW in the works, that tries to identify who is the primary user and will move the document to that geography. So we're very cognizant of where documents are being used around the world. That said, there is a special case when you are collaborating. You will use the modeling servers in the region of the first user. So if I open up the document in the US and Bruce Bartlett opens it in Australia, he will be using the servers in Portland, Oregon, and his time of flight will probably be around 100 milliseconds. So you'll start. It's potentially possible to start to see very, very small slowdowns. But of course, India 8.5 hours, Australia 12 hours, China 12 hours as well, I think. You're unlikely to be working on the same document at the same time. So if you do see a server location being used that's not what you're used to, it's probably because of a collaborator. How would you know which one you're using for any given document? So there is actually a debug panel you can get to with Control D. So if I, yeah, I should just do this. So if I come down here and I say, I'm interested in opening this document, and I say Control D, no, Command D, no, Control D. So this will tell me which region, US West 2, as expected, this document is being used in. So this is not my geographic region, this is the region that this document is being used in. And the other metric that you're going to see here is the ping time. This is a round trip from where I am back again. And you don't look at this number when Onshape is doing something, because that number will include the quote-unquote doing something. With your hands off the mouse, the steady state number is the time of flight round trip. So basically, if I subtract 32 milliseconds from, say, 80, I'm at 58 milliseconds for us to process your request, your ping, and and a response back. That's pretty good. Humans won't notice anything below about 100 milliseconds. Between 100 and 200 milliseconds will generally be perceived as being as fast as desktop CAD. If it's over about 200 milliseconds with your hand off the mouse, you might want to talk to your IT provider just to see if there's anything you can do. So again, that was Control D to get to that. Awesome. Next, also on this check, you saw that I ran a graphics test. It's interesting that when I did this, when I prepared the presentation, I was getting 130 million triangles a second. And here, while I'm giving the presentation and recording it at the same time, you know, my GPU is working pretty hard. I'm down to about 89, 90 million triangles a second. You want to be above about 20 million triangles a second. And it's very much a case of the haves and have-nots. The haves will see listed a discrete graphics card. It'll say NVIDIA or AMD or something other than Intel or Iris or CPU or something like that. It is entirely possible that you could have a graphics card on your machine, but the browser not recognize it. If you have a graphics card, but it says Iris or Intel, you need to go ahead and click on this link, Graphics Performance Recommendations, as well as visit the control panels for your graphics card, your NVIDIA or AMD control panels, to nominate or identify the browser as being one that is allowed to access your graphics card. Doesn't have to be high-end. A $100 gaming card will absolutely run just fine. And of course, there are many machines, Chromebooks in schools, things like that, that don't have GPUs, and they work just fine as well for anything except, you know, larger assemblies. Obviously, the people here on this webinar are professionals, and you're going to want to make sure that that is the case. Next, I don't know why it keeps doing this. Sorry. If you are struggling driving multiple large 4K monitors, there is a setting in your company setting that says don't match the pixel density on Retina displays, because two Retina external displays plus my laptop, I'm at 12K. You know, my ability to drive a high frame rate of 12,000 pixels is going to be a little bit compromised. So where you find that is if I go into my account, my preferences, and I look at my environment profile settings. There's the default one. I'm actually going to create one for the sake of this presentation. I'm going to call this Philip. And I'm going to say in this profile, do not try and match the pixel density of Uber monitors. And that will actually just reduce the number of pixels that my graphics card has to drive, increasing frames per second, things like that. Awesome. And of course, you can at any time go back to the Onshape default. Good. Next, let's talk about documents. A document is likely to contain parts in Part Studios that are unique to the project and likely not yet released, but also released parts and released assemblies. And of course, one of the things that we've noticed is a good practice is when you're going to an ideation phase of a design, you're going to want everything in the same document. You want everything to update quickly. You want to iterate a change to a part in a Part Studio, automatically update the assembly. But when you reach a Rev 1.0, you're going to want to move that Part Studio or that assembly out of the document. Now, you don't have to. I don't know why that included that. You don't have to, but there is a small performance benefit to the document and a giant performance benefit to you. And this is actually the golden rule that we're going to come to at the end. So why am I saying there's a small performance benefit to the document? When you open a document, all the all of the Part Studios and assemblies get assigned modeling servers on our infrastructure. And the more you ask for, sometimes the longer it takes to marshal those resources. If you have a document, and unfortunately customers have got themselves into pickles with 200 and 300 element documents, and then they say, why does it take 3 minutes to open? It's like, we're spinning up 300 servers for you. How long do you think it should take? So break up your documents where appropriate. This was meant to be a rule of thumb. generally around 20 elements seems a very reasonable number. That is not hard and fast. If you have 40, I'm not saying you're wrong. I'm just saying that it would take longer to open than it would take us to marshal the resources for fewer elements. And I'll come to what the giant performance benefit is to you at the end. That's the golden rule. So how can you learn more about how to best manage your documents? In the Learning Center, there is an excellent resource. It's the Product Structure Organizational Tips document. And let's just quit out of this for a second. Let's just jump there. If you've never been to the Learning Center, there we go. I'm just going to open a new browser tab. This is the document, and when you scroll through it, there are 10 or 11 tips. They're very well documented. How to manage and organize your document, how to break it up into smaller documents, and of course, we still have a highly requested feature coming, and that is the ability to make folders out of long feature lists and part lists. So there are some great tips here. In fact, here's the one we just talked about. In the beginning, you may have a number of parts or assemblies that you want to iterate on quickly early on in the conceptual stage, and therefore want them in the same document so the changes propagate automatically. And later, as the design moves closer to production, you might want greater control and update on new versions or revisions. In this scenario, again, the action is the ability to move tabs out of the document. This is a very comprehensive technical resource. Notice I'm talking about versions or revisions. I'm assuming as professional users that most of you are on Onshape Professional and have release management available to you even if you aren't using it, and therefore the ability to create revisions. If you don't use it or have Onshape Standard, you have the ability to version a document, which is almost as good, and you can still get some significant productivity, significant performance gains by using versions versus workspaces. We'll talk a little bit more about that in a moment. So there are some great resources here. Please take advantage of them. Please use them. All right, next. Let's talk about performance in sketching. So what I've done in each of these cases is I've tried to show a good and a bad practice and give you some sense of the relative difference in performance. Sometimes it's very hard to get anything other than a small change, and sometimes it's easy to show very large differences. So just to give you some concept, using one methodology, the regen time was 7.5 seconds, and 1,000 times quicker, 100 times quicker, 773 milliseconds. So there's something going on here. How can we improve the performance of sketches? So let's come to my sketch performance example. So here is a very complex grate that you all have parts that you can think of that have very long regeneration times. This one is no different. And sometimes when you're trying to sketch on faces, it becomes very slow to start a sketch and very slow to do anything. And I want to show you how to improve that significantly. So here I am opening a very, very complex part that would benefit from a lot of optimizations, but here we go. Let's just start a sketch on this face. Actually, I'm going to pick this face. I'm going to start a sketch. Watch the spinner, just starting this sketch around and around and around and around and around and around and around. What's it doing? It's actually imprinting. What it's doing, and then this is an analogy, is it's making invisible converted edges for every arc, point, and line on this entire face. That is thousands and thousands of entities. That's what that length of time was. And if I try and do anything like start a circle and I want to snap to the center of this edge, it's going to take a while for that to wake up because it needed to identify it was this one out of thousands. And when I let go of my sketch, what's happening is the sketch is being solved using the constraint solver, and again, around and around and around and around. So when I add the second entity, it's going to do it again. The third entity is going to do it again. And each time it gets a little longer. Wow, this will get painful and annoying very quickly. And in fact, the regen times on these, if I let it finish, are going to be really long. So I've got nearly 7 seconds here, 6.5 seconds here. The import was only 628 milliseconds. And by the way, the roundy round while I was opening it was the facetization. We're going to talk about that a little later as well. So let's compare and contrast it to this one. I'm going to facetize. It'll take a little bit of time, sorry. Should have visited this before the presentation. Here we go. If I look at the regen time of this, the sketch has a 14 millisecond regen time. So suddenly everyone's interested, what's the difference? The difference is that I'm skipping the imprinting. How did I do that? I created a plane that is 0 offset from the face. And now when I pick, I'm actually, turn this on, I'm actually, well, just make sure you start a sketch on the plane. The length of time to start that sketch was instantaneous. The length of time to add entities, instantaneous. The one thing I don't have is the ability to wake up these edges, because remember, there were no entities converted, but I can still create whatever geometric constraint I want, and I'm down and out. So done and out. So again, the import was the greatest portion of the rebuild, and the plane took 56 milliseconds, and each of these sketches 14, 13 milliseconds each. So what I did was I sidestepped the process of imprinting. And there are all kinds of threads on this in the forums. If you want the option when creating a sketch to skip the imprinting, I strongly suggest you create an improvement request, because that's how we get stuff changed around here. All right, I'm already gone to 31 minutes. I'm going to have to speed up, sorry. So that's the first significant performance tip for you. So let's move on to the next one. So imprinting can significantly increase solve time. If you only need a few constraints, add them manually, meaning create a 0 offset plane and sketch on that. You'll get a 100-fold increase in performance. Part Studios. This is a really cool assembly, right? Well, I'm not going to tell you the name of the document. It's actually a public document, so I don't want any of you making copies of it. But this has over 1,000 features and made nearly 3,000 parts. Oh my goodness. I don't want to tell you how long it took to open or how long it takes to regen, but this is not what Part Studios are for. A Part Studio makes parts, usually one. If the second part is not geometrically related, it goes into a new Part Studio. There is what we call a slippery slope, where you build the first part, and then you say, well, the second part has the same diameter as the first part. And then you say, well, this other part, the first part fits inside it, so I need to build it here. Stop. There are other ways, and I'm going to show you other ways of doing this. Only if the parts are directly geometrically related, meaning, for instance, there's a mounting face or hole that is cut through 2 or more parts. Yes, it's perfectly reasonable for those 2 or more parts to be built in the same Part Studio, because a single feature is going to geometrically affect all of them. Don't just build them in the same Part Studio because they're going in the same assembly. You don't, actually, the rebuild time was only about 2.5 minutes. I was actually very surprised. But this is, think about this. You are actually editing, I should back up. So in a Part Studio, there was no instancing, so patterns of these conveyors are all individual parts. The bill of material will be completely wrong. There are no mates and there's no motion. There is no benefit to building multiple parts of an assembly in a Part Studio. And of course, you can't separate any of these parts later. We get tickets all the time. I've got 1,000 features making 10 parts. I want to split them up. How do I do it? You simply cannot do it. And remember also that if I want to edit a feature of one of these parts and I edit an earlier feature, every feature below it is going to be regenerated, even if it doesn't geometrically affect the parts I'm trying to edit. Onshape has no way of knowing that a feature is not going to be needed to be regenerated in order to update your part. So don't do it. Next. This one made me raise my eyebrows, but when I thought about it, it made perfect sense. Put expensive features as close to the top of the tree as possible. When I thought about it, I realized that the person that gave me this tip was relying on the fact that it was a statistical likelihood that the more features that were below the expensive features, the less often the expensive features were likely to be rebuilt. If there's a whole bunch of features above it, we'll take the extreme case, right? This helical sweep is the last feature in the tree. That feature is rebuilt 100% of the time, that any feature is modified. Whereas if it's the first feature, unless you're editing that feature, there is a 0% chance that that will have to be regenerated. And by the way, helical sweep is the most expensive feature, or one of the most expensive features in any CAD system on any kernel. We happen to be based on Parasolic kernel. We have a very good working relationship with the people from Siemens. It's the best kernel in the world. It's the same kernel that we used at SolidWorks. It's the same kernel that drives NX and a bunch of other CAD applications. And moving on, Part Studios. I see this a lot, and in fact, we are at fault here because we told people to do this. Define variables only when you need them. Putting them at the top of the tree guarantees, I should just bold that, guarantees that all features will have to be rebuilt. It's very convenient to put these at the top of the tree. That way you can see what their values are, but understand that if you change this one, this gets reevaluated, this gets reevaluated, blah, 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 you get the idea. If you only define them at the time that you need to use them, it becomes a lot easier. Now don't forget, you can search and find them very easily. If I just type pound, in fact, let's just make one. I want to make a, let's make one of these. I want to create a variable example. Apparently I can't spell today. I am going to create a variable. Because I'm working on a much lower resolution now, I don't know where everything moves, so let's do length, can be a length, width, there we go, and we'll do height, and then I'll start a sketch, I'll extrude it, I will fillet it. Okay. You can see that it's very easy to move these around if I wasn't going to use them right away. Obviously, they have to exist before the feature that consumes them. I'm just going to make this a bit bigger. But don't forget, it's very easy to filter these things out. If I just type pound here, my feature tree is going to be filtered out to show me just the variables. So if I want to come in and change any of the variables, I can. And by the way, while I'm up here in the filter, people seem to have forgotten or didn't know that, for instance, you can actually filter out which features build which parts. So for instance, I'll shrink this down a bit. This Part Studio has 2 parts. And if I say colon part 1, I will see just the features. If I spell it correctly, there is no part called part 1. There we go. Part 1 is made of the extrude and this fillet, and if I change it to part 2, it's just this. Now understand that if a part is made by the Boolean of 2 others, then if you do this filtering, you're going to get all the features that made the 2 constituent parts to be Boolean together. If you want to know what else this can do, just put your cursor here, let it hover, and you'll see some syntax. You can search by name, a type, a part's name, or all parts. So that's a very useful searching tool. So spread the variables throughout your feature tree. And by the way, we are working on this. We want you to be able to collect them together at the top, and you'll hear announcements in the future when we've got that all sorted. All right, face patterning versus feature patterning. If you're previous or reformed SolidWorks users, you are very familiar with this. Cutting to the chase, a feature pattern in this particular example was 240 milliseconds versus 169 when I used the face pattern. So just quickly, we'll come up here. Here is a part, and the regen time is 240 milliseconds, and the linear pattern is a feature pattern. So I took that, it's actually a loft, and patterned it, and so that loft is being recreated every time. That is different from this one, which has a much shorter regeneration time, 169 milliseconds, and the difference, of course, is the fact that in exactly the same feature order, I actually said that I wanted a face pattern versus a feature pattern. So patterning faces says take the geometry that was created by the feature, which doesn't require any additional recalculation, it's just a trimmed surface, and then pattern it through the body and then do the sewing operations that you need. It is almost always faster than a feature pattern. When you are using feature patterns, the other option that you want to make a note of is the per instance. So if I actually need a feature pattern, in this particular case, this was a offset from a cylindrical face, so that there was a given wall thickness. I didn't actually need this. So if I said the regen time was 980 milliseconds, if I come down here and I change this to be not per instance, that goes down to 321 milliseconds, so almost a 1/3 of the time, 66% improvement in performance. Sometimes you do need per instance. What on earth does per instance mean? Per instance means that the end condition, that offset from the face, should be recalculated every time I reapply the feature. So if I had actually tapered this, and I said I want to draft this, it's 1 degree. So now that, let's go shaded with hidden edges, and I look at this side, you can see, actually I want, nope, don't want that, bear with me. I want hidden lines visible. So as that taper comes in, you'll see that I'm not doing the per instance. And if I come back and I say, I do need the per instance, I'm recalculating the end condition each time so that I have the correct offset. But there is a, sorry, I said second direction, I meant this. So you can see how as the bore tapers, that the depth of the pocket gets bigger, but then the instances that I pattern, or even if I have to do that, the instances that I choose to pattern around this shape do not need the per instance because they are actually already the correct depth. And I use in fact, I could use a face pattern on this. And in fact, let's do some quick performance stuff. If I want this benefit, but might otherwise choose not to because of the difficulty in picking all these spaces, let me show you an easy way to do this. I'm going to use my create selection capability. So I'm going to say, I would like to change this to a face pattern, and I want to get all the pockets, and these are all different depths. So I can't, if I say create selection, there's a button here that does the same thing, create selection. I can't say find this pocket, and then, which it does, and then say patterns of them. Well, you did, didn't you? Well, that was nice, even though they were different. Oh, because it is a pattern, duh. The other way would have been to do a bounded faces, and there are all kinds of webinars on how to use these advanced tools. But for now, we'll just say pick all the pockets, say yes, and the pattern will have been correctly propagated around the part. And of course, the regen time is even less now. It's 184 milliseconds, and each pocket is a different depth. So I went from 900 milliseconds to less than 200, so a better than 5-fold increase in performance just on the correct use of patterning options. All right, quick look at the questions, see how we're doing. All right, everyone seems to be okay. Thank you for a couple of bits of feedback. I will read the longer versions afterwards when you plow forwards. All right, next one. Slide per instance. All right, we went from 980 milliseconds to 154. Got it. Derive. So a parametric feature-based solid model will take a finite length of time to regenerate in all systems, and that length of time is roughly comparable. The length of time a sweep or a loft or a cut takes to regenerate in SolidWorks, CATIA, Creo, NX is about the same time as it takes in Onshape. It's the workflow that we're optimizing here. We're trying to make things faster than the tax that we have to pay to have, in this case, a parasolid model regenerate. So please understand that just because I show some things that are longer than others, it doesn't mean longer than everything else. It just means longer than the most optimal workflow in Onshape. So derive can be very useful or very expensive, but can be used to break up a long feature tree. So in this particular case, I'm going to show you a performance improvement that goes from 288 milliseconds down to 170 milliseconds. So let's do this. Let's come through. So in this particular case, I started with the block and the whole, and maybe I want to break up a very long feature list, something that's very, very difficult and time-consuming to regenerate. So I'll start here, and then I will derive from the first part studio. That means take the results of the first part studio and bring it here. And in fact, there's no penalty other than the length of time it takes to actually execute the derive. In this case, an additional 50 milliseconds, which is like a couple of features. And then I'll add some more in this particular case, the creation of that pocket. And then in the next part studio, I'll derive the first one, and you can see that this one had 135 millisecond tax, if you like, but that might be small relative to the 20 or 30 features that I want to put here, and we just keep doing it. So there's a small penalty for going from part studio to part studio where something might be machined in stages or the creation of a weldment. This is actually okay, but here is the thing that you have to understand. You're creating a chain of dependencies. The total time to rebuild this might be 259 milliseconds here because nothing had changed. If I was working on the top level, the length of time to regenerate this is actually only 73 milliseconds. Let's go back to the first one. There's not that much going on here, so 21 milliseconds. But if I change something, so let's change, for instance, we'll draft this, we'll go in 1 degree. Now you'll see a much longer regeneration time because, why did it not show longer? Because what it's actually having to do is to update all of these. Oh, no one was in them, sorry. The scenario is specifically that you'll see, I don't know if GoToMeeting is catching this, but when I click on this, you'll see the spinner, 3, 2, 1, click. Obviously, in order to make that up to date for this user, I'm having to use a modeling server to go back up the chain as far as I need to get the last good state and then bring it forward with the features. If you are collaborating and one person is in this part studio and one person is in this part studio, a change here would actually cause a much longer regeneration time because Onshape knows it has to work all the way down to here. So the regen time of this one will be the regen time of this part studio plus this part studio plus this part studio and this part studio. When we use the golden rule, you'll see how we can break that chain and stopgap it at various points. A lot of you have already probably figured out what the golden rule is. It is the ability to reference versions. So we'll come back to that at the end. All right, so you can break up a long regen time. In fact, John McCleary made a video on this to show how it's actually in the bearing ball to cage mate thread that was going on this past week. That was my one. And he actually posted a video. I'll just play it a little bit. You're all free to do it. Where he actually broke up using Derive, a very large part studio, and was getting about a 5x performance benefit. So it's real world. Check it out. And these are things that users are doing to maximize performance. All right, coming back to this. There are other ways of doing this. So you can break up a long feature tree. There is actually a better way. So let me show you, where is my ball bearing? My bearing. Well, since I posted it here, I'm guessing that there's a link to it. So let's, not that one. Where's my bearing? Here's mine. It is a public document. You're welcome to look at it. I tried to show good Onshape strategy. Although the cage, my bearing actually wouldn't rotate because I built the cage with the wrong orientation. Bad me. The cage actually goes over the balls, not around the balls. Bad me. But this is a good example of how to build up an assembly that has bearings, and of course the bearings move at half the balls move at half the difference in speed between the inner and outer races, which is kind of fun. How did I build it? I built this using a layout sketch. So I do have a variable for the ball diameter, and then I have a sketch in this plane and a sketch in this plane, and that's all I need to make all three, actually 4 parts. So as you walk from left to right, I could have built a ball, one inner race and one outer race in the same part studio, but then I wouldn't be doing the things that I told you should be doing. So what I'm actually doing here is, here's a part studio. I derive in the sketch, and I revolve it to make the ball. There's one feature, one part, boom, dead easy. Fast regeneration. Here's the inner race. I derive in the sketch. I make the sketch for the inner race. I revolve it. We're off to the races. 100% of the features in this part studio make this part and this part only. And of course, everything is related to the layout sketch. Same thing here. I start by deriving a sketch from the master part studio. And by the way, this technique is taught in the top-down management class. There's also a top-down self-paced set of tutorials in the Learning Center. So then we go to an assembly. I put one steel ball in. I bring the layout sketch in because I need the axis. And then I created a circular pattern. This is awesome because the bill of material, ball instance 12, whatever. There you go. Versus had I patterned them in the part studio, it'd say part 1 instance 1, part 1 instance, sorry, part 2 instance count 1, part 3 count 1, part 4 count 1. So this is absolutely the right way to do it. The magical mate that people seem to miss is the group mate, which holds everything in a fixed relationship relative to one another. And then you put it together. I've got the inner race, the outer race, 1 revolute for the inner race, 1 revolute for the balls. And then I have a couple of revolutes to position the cage, and the cage is built in context. So if you can't remember how in context works, there are all kinds of webinars on in context. Just to show you that everything updates, let's come back to here and say the ball is actually now 8 millimeters in diameter. And anytime I visit a sketch, sorry, part studio, you see everything is updated appropriately, blah, blah, blah. It's not going to give me the radius. So there we go. There's the outer race. There's the pattern of the steel balls. The only thing that's off now is the cage, right? Because the cage is too big because the ball changed size. So I just update the context and spinner, and then of course, because there's a bunch of modeling operations, and then of course the cage will update to be the right size. Takes about 8 seconds. Boom, context successfully updated. There we go. Sorry, I knew it's wrong. I realized this yesterday. There's a very face palm moment. You can all laugh at me. I actually have a master's degree in aeronautical engineering. Go figure. All right, so I'll say show instances. So that was an example of how to use the layout sketch. So now that I've got you excited about layout sketches, let me tell you how to use them and how not to use them. So derive once into each part studio. If I derive this on one time, there's actually 1, 2, 3, 4 sketches, 9 milliseconds. If I derive them multiple times, I'm at 32 milliseconds. Who on earth is deriving the same sketch multiple times? Well, let me tell you. Here I have a part studio that contains the sketches that I would want to derive. Here's an example where I bring all of them into one part studio at one time. I'm free to reference them, do whatever I want with them, extrude them, not a problem. The reason that people start to derive them multiple times is that this is an on or off proposition. There's no way to individually turn off the constituent parts yet. This is one of those areas that we're working on because we know what people do. What they actually do is they insert it multiple, do a derive multiple times. So if I edit the derive in this part studio, you'll see that I have selected all of the constituent sketches that I'm interested in and brought them in one time into my part studio. In this particular case, the user comes along and they say, I just want this sketch, then I want this sketch, and then you're smart people, you can figure it out, one for the third sketch, one for the fourth sketch. This is terrible, 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 because what's actually happening in the background is that we bring the entire contents of the part studio, even if there were 1,000 parts and you only wanted one sketch, that's another reason to only have very, very few parts in any given part studio. We bring them all in and then delete the bits you don't need. So I'm begging you to only derive one time from each part studio. That said, there is clearly a performance, or there's clearly a usability benefit to be able to turn these on and off individually. What are we going to do about that? My gift to you, my audience, is a custom feature called Onshape. It is a custom feature, it's a public document. So if I say open link document, you will see that it is in fact a public document written by our own illustrious and incomparable Ilya Baron. It's called Onshape, one word. Go ahead and add it to your toolbar along with all your other favorite custom features. What this actually does, it's a whopping 26 lines of code. It actually breaks up that derive. The way it works is you apply the custom feature, you pick one entity from the sketch that you want to control, and it breaks it out. So now I have the ability to hide and show the sketches individually. And the length of time that this takes is less than, so 19 milliseconds total. And now, of course, these scale up, right, if you do this at scale. 19 milliseconds versus 35 milliseconds, almost double the speed, half the length of time. And that's by using that process. If there was more in the source part studio that I'm deriving from, the performance gap would be even bigger. Everyone is now linking to the Onshape custom feature. It's very cool. All right, next one. Levels of detail. So there was a finite length of time that's actually not shown in those regeneration times. Those regeneration times are purely the length of time it takes the mod servers to execute the actions and update the geometry. After that, we have another service that facetizes, and then we compare the facets created to the facets that are cached in your browser. If they're the same, we give it a thumbs up. Your graphics card just starts rendering the triangles you already have. If it's different, we transmit the triangles. Well, for any geometric change, some triangles are going to be transmitted. The number of triangles that we have to transmit is going to be dependent upon this setting. So if I have a very complex piece of geometry, we're back to that plate that has a bazillion holes in it, you will see that at a low resolution, these look a bit like hex nuts, but the time taken to open this document is significantly less. So the only metric I have is how many revolutions. So click, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so 12.5 revolutions when it's at the low session, and this applies anywhere that I've used it, right? If I've used this in this assembly, it's going to be a whole bunch of triangles need to get transferred. So 11.5, if I edit the appearance and force this to, I'll just go to medium because this can get, it's about, I'll give you a clue, it's about 30 revolutions for very fine. So I'll say medium, it says yes, increasing tessellation detail can have a negative impact on regeneration. There are automatic settings where we try and find a happy medium, and in fact in the assembly you'll see that there are actually settings for controlling which level of detail is invoked. I'm finding that for simple parts, I'll just cut to the chase. For simple parts, leave it at automatic. For complex parts, you should control it manually. So if I do it this time, how long does it take? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so that was about the same. So usually it's 2 or 3 more. Of course, I could have just, my computer could have been doing something at that particular moment in time, but you can clearly see that there are, smoother edges now. And if I went all the way up to fine resolution, you would see that, it takes about 30 revs. So the fewer triangles you push around, the better. If you have a small fiddly part, you need high resolution, feel free to crank it up. If you don't, the lower, the faster it is. There is a setting here that says use best available. So that means that it's basically the choice between the highest resolution you ever rebuilt it at for the automatic setting. So if I say use best available, the best available is actually only that medium setting. And if I forced it to coarse, the best available would be coarse. If I set it to automatic in the Part Studio, then this could have used a higher resolution. And you know that you potentially have created an undesired burden. You've got this little symbol that I can't remember what it is. Maybe if I crank up the size of my icons a bit, I'll eventually recognize what it is. Maybe one of you smart people will remember what that is. It looks like a medal on legs or a sunflower, who knows? And let's just reset this. I need to have a quick look at my question list to see if, John, you're there. There you go. I gave you your video a plug. Thank you. All right, so we toggle between best available and automatic. Automatic in the assembly does mean if you've specified something at the Part Studio level that you will use that versus an automatically chosen one. Okay, let's move on. Assembly configuration. Be careful if you're using a large, air quotes, number of configurations from a single Part Studio. Each first use of a configuration requires that configurations be rebuilt in the source Part Studio, if you're referencing a workspace. Can lead to unexpectedly long regen times, such as changing configurations in a Part Studio. We'll talk about that last one in a moment. So this is horrible. This is something that I know the names of 3 people that are working on to fix this. This is BS. There's no reason we should have to do it. That you should have to be aware of this. It's going to be fixed, if not in 2 weeks, in 5 weeks. Let's see. All right, so here's my Part Studio, and I have 5 configurations, A, B, C, D, E, 20 turns, 40 turns, 60 turns, 80 turns, 100 turns. These can take a long time to regen. I'm just working with A. Notice that 2 parts are being generated. When we test CAD stuff, we always do helical sweeps. It's one of the most expensive features that you can engage in. Length of time to rebuild this instance is 76 milliseconds. But if I make a change to, say, the diameter of this coil, I actually have to rebuild every configuration. And a nuance, a couple of years ago, Ilya Baron posted an article about microversioning. If you want to Google it, it'll give you some better insight into what's happening. If I am looking at config A, I'm at a different microversion than if I was looking at config B, which means that switching configs actually requires that I rebuild it. We're fixing this, but just understand that even switching configuration rebuilds the Part Studio. So if I'm using these in an assembly, then and I ask for a particular version, a particular configuration, that this Part Studio has to switch to that configuration and rebuild it. And in fact, in terms of length of time, here is an assembly that references config A of this part, config B of the same part, config C of this part, config D, config E. This is going around 8, 9, 10, 11. You get the idea. It's going to actually go around about 30 times before it completely comes up. I'm running out of time a little bit, so I'm going to short circuit this. I'm going to show you a couple of things that are really going to improve performance. So in this particular case, what I'm actually doing, there is a Part Studio here in which I have actually derived each of the configurations one time. And the assembly is never touching the Part Studio that these came from. It's going to be doing this for a while because it's rebuilding 5 of these, so I'm just going to have to wait. And in fact, this is probably a lot of the frustration that you guys are going through, and is a good build up to the golden rule, which quite honestly is reference versions of anything. So this is a Part Studio in which I have derived a specific configuration. So in this case, I brought in Part 1 at config A. Yes, I brought in another parts that I didn't need or particularly want in the Part Studio, and I'd already explained that behind the scenes we're actually deleting one of them, but this actually has a significant performance benefit because I'm not regenerating the Part Studio each time. So in this particular case, by having one of each of these in here, I'll just show all, you'll see all the parts. When I come to this assembly, 1, 2, 3, about 7, 4, 5, 6. Obviously, it's referencing Part Studio 2, and it's bringing the instances in that were derived into that Part Studio. It's actually going to be a lot faster. Again, I'm not going to make you sit here and go through all this, especially since I'm running out of time. I'm going to cut to the chase here. You should absolutely, so that was about a third of the length of time that it took for the other assembly to update. The ultimate, of course, is to, and that was instantaneous, to reference versions either in this document or an external document. This is the end result of this presentation. You can either sit here looking at spinners or you can have instant access. Please, please, please reference versions of everything. So we'll come down here. The changing figs in a Part Studio, that was to explain that you're at a different micro version, and the Part Studio will be quote unquote out of date, because if your assembly asks for a micro version that you're not in, your modeling server has to jump to that micro version. The golden rule: every example up to now is relying on the Part Studio being up to date and regenerating when it isn't. Every example will slow the interaction with the Part Studio because the modeling server will run off and update all dependencies. The star here means two things. One, that means if someone else is using one of the dependencies, then your modeling server will run off and update their element before coming back to you. And the second meaning of this asterisk is we're going to fix that. We're going to actually have an army of modeling servers roaming around. This is part of the parallelization. If you read my blog post on has parallelization finally arrived in CAD, this is what we mean by it. We're going to deploy an army of these things to make it even faster. So the golden rule is, wherever possible, reference a version or a revision. And I would like to show you how to do this. We'll do a quick large scale ooh, ow, wow, and then I'll show it and we'll sign off. So let's find the twin. I'm opening this cold. It's about 1,000 parts. I have manually controlled the resolution of a number of these components so that they actually, I opened in the wrong Part Studio, sorry, wrong element. So here is the full 1,000 parts. There we go. That took about 3 seconds to open. If you want to open your 1,000-part assemblies at 3 seconds, feel free to do what I do. And then, of course, for the drawings, notice very, very clearly, these drawings are referencing versions of the assembly. I'm not pulling this over in real time. I can go ahead and detail this section there, put bills of materials on, do whatever I need to do. If and when a newer revision or version becomes available, feel free to switch to it. This one takes a little longer. It's the exploded view. So there you go. And I'm sure this is opening faster than many of your drawings. And the reason is I am referencing a version. Let's quickly do it. Let's make a new document. Version referencing, I can't type or spell apparently. Referencing. So I'm going to make 2 short-circuiting a number of things. There's 2 parts in the Part Studio. I put them into the assembly. Part 1, Part 2. Boom. If I change anything here in the Part Studio, perhaps I fill it. You know, these edges. Okay. Just goes ahead and update. After a while, you're going to find that the Part Studio takes longer and longer to regenerate as more and more parts of greater complexity are created in this and other Part Studios, and the assembly becomes more and more complex. The slowdown is due to the fact that every time I make a change here, my modeling server is going to run off and update the assembly. How do I stop that? I stop that by referencing version of this. So I can say right mouse button, change to version, and there is no version, so I'll go ahead and just version this document. I missed that. So we'll say change to version, and we'll just say yes, update all. Right, and there we go. It's a version in this document, and I'm going to say change to version here. That's right, update all. And now I should have done the regen time here, but the regen time will be less because the assembly is referencing a version and doesn't have to update. Now, if I make a change here, so I say remove through all, and I just take a look at this. Of course, it hasn't updated. As soon as I version the document, the assembly will say, hey, I'm out of date. Do you want to update to a newer version? I go, yeah, sure. Okay, I'll do that. So I say update link documents, and I'll go from version 1 to version 2. Now I get the whole. But this is a bit misleading because let's say I come back here and I say I want to fill out this space. I make a version. Why is it saying both of these are out of date? That's not true. Only this one is out of date. So this is where I tell you you're going to want to use revisioning because you'll get so many false positives, especially for standard parts documents where you might have a lot of part studios, a lot of parts in it. In order to make a new part available to the organization, you either have to make it not rev managed or you have to version the entire document. It is actually much better to use release management and just rev this. So if I say I want to release this part, the way I have my company configured, I have to put some stuff in. I am allowed to self-release. I'm sure there's a joke there somewhere. So this is that's now released. Let's go ahead and release this part as well. This will go to Rev A. Also, I'll go ahead and release it. It's actually much better. This is saying that there's a newer version of the document. At this point, I'm actually going to change to update linked document. That's what I'm looking for. I actually want to change to revisions. Revisions are much better. So I say for part 1, I want to go from part 1. I want to go to here. Update selected, yes. And I want to go to update linked document. I want to go to revisions of part 2. Come on. The latest revision. So now, still saying out of date, so I want to update link document. And there are entire, come on. There we go. There are entire webinars on how release management works. So now I'm linked to a named revision. And now, if I come and make a change here, and I put a ELD whole, I say remove through all. I want to re-release part 2, so I say release. It will go to Rev B. I will self-release that one. Now, when I come to the assembly, it's going to say, I think I pointed them both to the same release. That's totally my fault rushing. My apologies. Let me point this to. This one is going to go to the release version. It helps if I do it slowly, doesn't it? This one, I bet everyone was screaming in the. I bet everyone was screaming in the questions that I had done it wrong. So let me just do it right. That one is going to go to Rev B. Good. These are now both at the current release date. Sorry, I'm trying to do it quickly and ended up taking longer. So I'll come here and we'll say, all right, we want to fill it this. I'm going to re-release part 2. It will actually go to Rev C. And when I come back to the assembly, Only one of these is shown as being out of date. This is one of the most significant benefits of revision management, the fact that I know that only this one is out of date. And when I say update the linked document, it'll go from B to C. I'll go ahead and do that. Awesome. All right, I went over by about 10 minutes. The golden rule is wherever possible, reference a version or a revision. Of course, revision is preferable. If you're going to derive, only derive once from each part studio. If you need to, use the own sketch custom feature. Level of detail will increase the speed at which stuff opens and spins around. You can use derive to break up long feature lists. Understand though that it can take slightly longer, especially if you build up long chains of dependencies. The other way of doing it is the layout sketch methodology and workflow. Apply per instance only if you need to control the or recalculate the end condition each time. And of course, face pattern is always faster than either a per instance feature pattern or just a straight up feature pattern. Put the variables only, find the variables only when you need them. We're working on fixing that. And put the most expensive feature close to the top of the list. Don't build a bazillion things in one part studio. I'm done. Let me have a quick look at questions. Thank you for the kind, Owen's there as well. Hey, thanks, Owen. I guess you're up a bit late this evening. Bill, John here, full house. Actually, David Wimberly, sorry if I butchered your last name, that's actually a good suggestion you made. So for the avoiding the imprinting, John was saying that it might be an option to have a plane created on a face versus a zero offset. What I want you all to do is to go ahead and create enhancement requests for the ability when creating a sketch for a checkbox that says don't imprint, which would be a lot better and then just be a lot faster than that. Let's see. Wow, a lot of questions. David Harris, I know. Yeah, David was talking about breaking up large documents. It is a pain, which is why we ask people, we'll think of a better way. The real reason we haven't done anything better yet is we haven't thought of a better way. The document that I pointed you to in the Learning Center has some great resources for how to break it up today. As soon as we think of a better way to break up documents, and we are thinking about stuff, we have meetings all the time where we discuss this type of thing. Let's just say that we're not wed to the idea of a document. Let's see. Ed, yes, a couple of you had posted results of your check. Yes, some Chrome tends to be faster than Firefox, although Firefox does a better job of memory management. For instance, I have a 50,000 part assembly that I can open in Firefox, but not in Chrome. Just bear that in mind. And that's on exactly the same machine. We all use MacBook Pros around here. No one's had a new laptop since like 2014. I think Cody had a new laptop. You know, these are old machines. I do have an NVIDIA mobile graphics card. Yes, I can open a 50,000 part assembly on a 2 gig graphics card. All right, you've been very patient. All right, I think I've got most of the questions. Gentlemen, there's a lot of you here. Thank you very much. If you have feedback, please send it to Kim. If you have any questions for me, please feel free to send them to pthomas@onshape.com. And it's been a pleasure presenting to you. Hopefully your assemblies and your documents and your drawings will be faster for having attended. Thank you very much.